project, we aim to design an air conditioning system for a corporate office on one level in a building consisting of multi-section area. Air conditioning can be defined as the process of altering properties of air in a space interior to improve comfort.
Now I'm going to present about the methodology of the overall project. First and foremost, a drawing of the corporate office space is first produced using 100% SolidWorks software. Second, the specification and purpose assumption for each room of the corporate office is then done with included occupancy, purpose, and activity done in the room. Third is the comfort condition for each of the room is determined using the CBE tool and it then is tabulated. Fourth, based on the predefined information of the specific assumption, the cooling load, airflow, and also material calculated using HAP software is been done. And then fifth is the manual hand calculation is done for R1, which is Office 1, based on the CLTD method with the purpose of verifying the software results. Second last is the design of the air duct along with the AHU has been done. And finally, the green buildings criteria and BIE calculation of the corporate office design has been calculated and been done.
Now I'll be explaining about the design of our project. Without further ado, let's begin. Here is R1, which is office number 1, which is used for sales department. Underneath here we have R2, which is the conference room for meeting. And here is R3, which is used for marketing department. And here we have area number 1, which is for reception and waiting area. Moving on it we have R4, which is office number 3, which is according for the accounting department. Here we have area number 2, which is for printing area. Here we have T1, which is men's restroom. And here we have the R6, which is mechanical and storage room. And here we have R5, which is used for human resource and IT department. Underneath here we have T2, which is the women's restroom, and finally we have K, which is the pantry of the office. And overall, as you can see, we have all the doors and window that is put inside of this design, and all of the doors and window are same and standardized. And for the information of the walls of the room itself can be seen above the screen. That's all. Thank you.
Thermal comfort based on Asri is a thermal comfort is a sensation or condition of mind that express satisfaction with the thermal environment and is assessed by subjective evaluation. Different situations may yield a different sensation to human body. For example, in winter we need to feel a little bit hot, and in summer we need to feel a little bit cold. And we use CBE thermal comfort too, and the standard use is Asri standard 55-2070. Affecting thermal comfort, the first one is physiology, and MET or metabolic rate in this project is 1 until 1.4 depending on the type of work being done. The clothing factor is 0.61 because all the types of clothes worn is the same in the office. And also the environmental factor, air velocity is in the range of 0.1 until 0.4, and the relative humidity depends on the type of room, from 50% in the office space, and also for example in the printing room it should be more than 65%. The example of the parameters being set in the CBE thermal comfort tool, and we can see that the sensation get is all the neutral based on the MET, CLO, SP, relative humidity, and other parameters being set. I show a few examples of the parameters being set in CBE thermal comfort tool for each room, and all of them complies with the standard of Asri 55-2070.
A very good day to Dr. Khaled. Today I will explain about the HAP program. HAP used for designing HVAC system for commercial building and powerful energy analysis capability for comparing the energy consumption for the building. So first of all, we have set the region space, which is Penang, and the latitude at a 5 degree north. Next we have set the floor area and average head ceiling for the zone R6 in the office. Next we have set the internal properties such as people, lightings, electrical equipments with certain parameters that we set in for the building. For the wall properties, we have set the outside surface color and light, and we have set a certain materials such as face brick, gypsum plaster, and lightweight concrete with a certain thickness. Next, we have set the value for the door properties, which is the gross area for the door, which is 1.695 meters. Next, I have created the air system properties for the R6 zone in the office. Based on the report, the sensible load value that we get for the R6 zone is 732 watt, which will be used to compare with the manual calculation later. These methods will be applied for all the other zones.
In order to verify the HAP analysis, we did a manual calculation for Office 1. So we started off with the psychometric analysis where we obtained the outside condition from table A2 and the inside condition which is predetermined from the online tool. Next, we also calculated the cooling load where each values is shown here. And then we proceeded to add them together in order to get the Q-sensible total, which is 2585.03 watts, and it is compared with the Q-sensible from the HAP, which is 2800 watts, with a discrepancy of 7.68%.
Okay, now we'll talk about the A duct design based on the data collected from thermal load analysis using HAP software. The enthalpy value can be obtained, and we will get the flow rate and multiply it by specific air volume. We will get the volume flow rate of each room. Actually, this is our group flow plan. Then the blue line representing the design for supply A duct system, and then comes the design for return A duct system in yellow color line. The main duct for both system is at this left end. This is the methodology to obtain the AHU fan power required to overcome the total pressure loss, and also to determine the equivalent rectangular duct size. Finally, the result. The total pressure loss for supply A duct system is 21.473 kPa, and the fan power required is 33.962 kW. For return A duct, the total pressure loss is 19.265 kPa, and the AHU fan power required is 30.47 kW.
Now I'm going to explain about the Building Energy Index. Building Energy Index is defined by the ratio of the annual energy consumption of a building in kilowatt hour per year and the net floor area of the building based on the National Building Energy Intensity Marketing of Government Buildings. It was used as a benchmark instrument to track the efficiency of the building energy by observing the strength of the energy achieved per meter square of the particular building. As you can see here, here's the data calculated, and also of all the room, and the total can be seen on the table below. Next, we find the annual energy consumption by taking the value as before from the table times 53 weeks times 5 days, and we will get the value of the annual energy consumption. Once we get that, we need to find the net floor area, which is the area for all of the floor and also area in the office. Once we get that, then we can find the BEI, which is annual energy consumption over net floor area, and we will get 199.431 kilowatt hour per year meter square. Based on the National Building Index labeling for the government building, our official building is placed on 2-star rating, as can be seen in the figure on the right. So this is the first slide of the discussion, which consists of 2 paragraphs. Here's the second slide of the discussion, which consists of 2 paragraphs. And here's the last slide of the discussion, which consists of another 2 paragraphs. In conclusion, an air conditioning system which can provide maximum power of 4,339 watts is required for the office to maintain the thermal comfort. Besides that, the total cooling load percentage difference between the manual calculation and HAP is only 7.68%. Therefore, can be said that the hourly analysis program is reliable to be used in calculating the cooling load of the building. Not only that, our design complies with the EDGE Green Building Standards in terms of the wall-to-wall, window-to-wall ratio, reflection pane of the external wall, energy-saving light bulbs, and lighting control that will contribute to the energy-saving measure. Along with it, the Building Energy Index that we get for our design is 199.1431 kilowatt hour per year meter square, which is placed on 2-star rating based on the National Building Energy labeling for government's building.